Hello, so this is a revision video for AP Chemistry 7.6, Properties of the Equilibrium Constant. The equilibrium constant K is a value that indicates the ratio of product amounts to reactant amounts in an equilibrium system, Kc referring to concentrations and Kp referring to partial pressures. You need to know some basic rules for how K changes with certain manipulations. For example, reversing the reaction. If a reaction is written in the reverse direction, the equilibrium constant becomes the reciprocal. For example, for the forward reaction A going to form B, the equilibrium constant Kc would be concentration of B divided by concentration of A. However, the reverse direction, so B going to form A, would have an equilibrium constant Kc of concentration of A divided by concentration of B, or in other words, 1 over the Kc value for the forward direction. Multiplying a reaction. If all coefficients in a reaction are multiplied by a factor n, the new equilibrium constant is raised to the nth power. For example, for A going to form B, we've just seen the Kc expression would be Kc equals concentration of B divided by the concentration of A. So, for 2A going to form 2B, the Kc expression would now be concentration of B squared divided by the concentration of A squared. Or in other words, the Kc value for the first reaction squared. Adding reactions. When two or more reactions are added together, the overall equilibrium constant is the product of the initial K values. For example, let's say reaction 1, A going to form B, has a Kc value of Kc1, and reaction 2, B going to form C, has an equilibrium constant of Kc2. For the overall reaction, A going to form C then, the Kc value would be Kc1 multiplied by Kc2. So the equilibrium constant for each reversible step multiplied together to give the overall Kc value. It's important to remember that the same rules that we've just used here also apply to Q, the reaction quotient, and Kc and Kp work in the same way as well. Exam tip here, don't forget that when working with Q and K, the concentrations used in a Q expression, so reaction quotient, don't have to be from when the system is at equilibrium. However, all values used for a K expression must be equilibrium values, so concentration for Kc or partial pressures for Kp.